The lesson outcome for this video is I can solve radical equations. So there are two steps we need to be aware of for solving radical equations, and they are, first, we're going to solve for x by undoing the order of operations, and then secondly, we need to check for extraneous solutions. So I'm going to talk a little bit more in depth about both of these things. First of all, remember that the order of operations is P, E, M, D, A, S. A lot of times we say PEMDAS, or we use please excuse my dear Aunt Sally to remember the order of operations. Now remember, when we solve by undoing, which we have done with quadratics in vertex form as well, we solve by starting down here and moving our way up by undoing the steps. So we start by adding or subtracting, then we multiply or divide to undo things that are being done, and then we deal with our exponent and our parentheses. One thing I want to add to this list is that we now will add radicals right here next to the exponents. So just like addition and subtraction undo each other, and multiplication and division undo each other, exponents and radicals undo each other. Some people actually call this PEMDAS. So more on that as I show some examples. Now the second thing, check for extraneous solutions, means that we are looking to see if there's an apparent answer that doesn't work in the original equation. All right, if we have an answer for x, let's say we get x equals 2, and we check it back into the original equation, and if it doesn't actually work to make the equation true, it is an extraneous solution. And I'll show an example of that as well. Okay, so what you see here is a radical equation because we've got a square root of x plus 3 equals 4. Again, to solve this, we're going to use the reverse of PEMDAS or PERMDAS. We are going to start by adding or subtracting and move our way up. So, first thing I need you to notice is that when I say adding or subtracting first, we cannot deal with this addition right here because that adding 3 there is stuck in this radical, and radicals are way up here. So there's no adding and subtracting to do. There's no number out here to multiply or divide by, and or it's not being divided by a number. And so we need to continue our process by looking at exponents or radicals. Okay, so there is a radical, and we want to undo the radical, so we use exponents to do so. All right, so we are going to use an exponent. We're going to raise this square root of x plus 3. We're going to raise it to the second power because a square will undo a square root. And just to make sure you understand why that is, if I had the number 9, okay, I'm starting with my original number of 9, let's say, and I decide I want to square root it, which is 3, but then I decide that I want to square that. I have 3 and I square it, I get back to 9, which is my original number that I had. So a square root and a square will cancel each other out. So up here, back up to this problem, if I square one side of the equation, what do I have to do to the other side of the equation? Well, I need to square it. You have to do the same thing to both sides of the equation. So the square root will cancel out with the square right here. So again, this whole square root sign is canceled out. That's kind of how I show this right here. So all we have left is x plus 3 from underneath the root. So x plus 3. And that equals 4 squared, and 4 squared is 16. Now if I subtract 3 from both sides, I am left with, because I'm undoing, I should have stopped there for a second, because I'm undoing the addition with subtraction. And I end up with 16 minus 3, which is 13. Now before I circle this answer, I want to make sure that it works in the original equation. So, going back to my original equation, the square root of x plus 3, I'm going to put my x value of 13 in. And I want to know, does this equal my original 4? Okay, so again, I'm using this, the square root of x plus 3, that's right here, equals 4. And we want to know if it's true with the value of x that we just found. Well, 13 plus 3 is 16, and the question is still, is the square root of 16 4? Yes, the square root of 16 is 4, and that does equal 4, and it checks out. which means that we know x equals 13 is a solution to the equation. Now if I did the same work over here on the right-hand side, because this equation is almost the same as this one, so if I did the same work, I start by squaring both sides, square this, and square this. My square root will cancel with my square, and I'm left with x plus 3. And on the right-hand side, negative 4 squared is negative 4 times negative 4. Since a negative times a negative is positive, I have 4 times 4, which is 16, and it's positive. Okay, now I subtract 3 just like I did in the previous example, and I end up with x equals 13. Same answer. Now the question is that correct for the original equation? So let's put the 13 in here again, 13 plus 3, and the question is, does that equal negative 4? Well, 13 plus 3 is 16. Does that equal negative 4? Well, no, the square root of 16 is 4, and 4 does not equal negative 4. So this is an example of an extraneous solution. X equals 13 is an apparent solution that does not actually work in the original equation, making it the final answer for that example to be no solution. All right, so this example we're going to run through more of the PEMDAS steps or PERMDAS steps than the previous example had. Remember, we're going to start at the adding and subtracting. We're going to undo addition or subtraction, then multiplication, division, exponents and radicals, and lastly any parentheses. So we'll start by adding or subtracting anything. Again, the 6 is in the radical, so that's up here. But this negative 4 we will undo. So we're going to add 4 to this side of the equation and add 4 to this side. When we do that, on the left-hand side, we're left with 2 times the square root of x plus 6. These cancel, and 0 plus 4 is 4. Next, we deal with multiplication or division to undo, and we're going to divide by 2 so that these cancel, and we have to divide over here by 2 as well. So we get the square root of x plus 6 equals 4 divided by 2, which is 2. We will undo our radical. At this point right here, we undo the radical with an exponent. So I'm going to take this side of the equation and square it, and then I have to take this side of the equation and square that as well. The square root and the square will cancel each other out, and we have x plus 6 equals 2 squared, and 2 squared is 4. Lastly, we will subtract 6 from both sides, and we get x equals 4 minus 6, which is negative 2. Now remember, extraneous solutions, it doesn't mean that a negative value doesn't work. Nothing like that. A negative value is fine as long as it makes the original equation true. So we are going to go through and double check that that is going to work. I'm going to show all my work on this one on examples later in the lesson. I might just walk through them without showing all the work. So here's our original equation from right here, right? 2 times the square root of x plus 6 all minus 4 equals 0. We're going to put the negative 2 in for x. So the negative 2 that we just got right here goes in for x. And we want to know, does that equal 0? That's a question mark right there if you can't tell. Okay, so we simplify. We start by simplifying negative 2 plus 6, and negative 2 plus 6 is 4. So now we have 2 times the square root of 4 minus 4. Does that equal 0? Next, we're going to square root the 4. So we get 2 times the square root of 4 is 2 minus 4. Does that equal 0? Remember, the order of operations in the normal order, going down right now is what we're doing, so we need to multiply or divide first. So multiplication, 2 times 2 is 4, and 4 minus 4, does that equal 0? Well, yes, 4 minus 4 does equal 0, so it checks out, and this is a solution. Okay, so let's try just 2 more examples. Now, if you would like to pause the video and try them on your own and then come back and check to see how you did, you sure can. Otherwise, you can watch me walk through a couple of these and include them in your notes. Again, we are going to do the reverse of PERMDAS. So if you want to write that down somewhere to follow through, you can. Again, if you want to try these yourself, go ahead. All right, so the first thing we need to do is add or subtract to get rid of any addition or subtraction, except for the addition that's stuck inside the root. So the addition of 3 here we need to undo by subtracting 3 from both sides of the equal sign. All right, so these cancel out, and we are left with 2 times the square root of x plus 5 equals 7 minus 3, which is 4. We're now going to undo multiplication or division. So I'm going to divide both sides by 2 so that these cancel. I'm going to be left with x plus 5 in the square root, and that equals 4 divided by 2, which is 2. At this point, this problem looks a lot like we saw on the second slide of this lesson. We are going to square this side here to get rid of the square root, and if we square that side, we also need to square this side here. The square root cancels with the square on the left-hand side. We are left with x plus 5 equals 2 squared, which is 2 times 2, which is 4. Lastly, we're going to subtract the 5 from both sides of the equal sign. These cancel, and we get x equals 4 minus 5, which is negative 1. Now, if we went back up and checked this answer, negative 1, right here, we would get negative 1 plus 5. Follow along here. That negative 1 plus 5 is 4. The square root of 4 is 2. We then multiply that 2 by 2, and that's 4. And then the 4 plus 3, and 4 plus 3 is 7, which does equal 7. So this checks out as a solution. You might want to actually show your work for that somewhere. I just knew I was kind of running out of space. Okay, so maybe you tried this next one on your own. Again, the first thing we would normally do is add or subtract, but there's nothing to add or subtract in here, so we are going to go directly to multiply or divide. All right, so multiplying or dividing, we are going to divide by negative 4 on this side because that'll cancel, and we have to remember then to divide by negative 4 on this side. Negative divided by negative is positive. So we're going to get a positive 40 divided by 4, which is 10 on the right-hand side. And on the left-hand side, we have x minus 3 in the root. We are going to now deal with the exponent or radical, and we are going to square both sides of the equation. The square root and the square will cancel. We're left with x minus 3 equals 10 squared. 10 times 10 is 100. Notice it is not 20. And lastly, we add 3 to get our x variable alone to find the value of it. So x equals 103. 103. Again, if we want to check that in our original equation, we'd have negative 4 times the square root of 103 minus 3, and we want to know, does that equal negative 40? Okay. You might be thinking that since this is a negative over here, it might not work, but it actually will be just fine. Let's walk through it quick. So 103 minus 3 is 100. The square root of 100 is 10, and 10 times negative 4 is negative 40, and that does equal negative 40. So this is the solution to that equation.